Welcome to Lab 1, Charge Tapes. My name is Abrar. I hope you're all having a good day. So in this experiment, we'll be going over concepts related to the idea of charge as a property of matter, how neutral and charged objects interact electrically, how vertical forces can affect the momentum of objects, and the amount of excess charge on everyday objects. The goal of this experiment is to determine how much excess charge is on one piece of charge tape. We will be calculating the charge contained on one piece of charge tape and all the vertical forces that act on that piece of tape if another piece of charge tape is held onto it, which temporarily causes it to float or hover. Okay, so the procedure for part 1. So the first part of the experiment concerns using the interaction of known charged objects with unknown charged objects to determine their charge. So first we need to charge the tape. We place a piece of tape face down after making a hook, then we place another identical tape on top. The tape on the top should be charged. To determine the sign of the charge of the tape, we charge the head of a plastic pen by rubbing it against a piece of cloth. The plastic end of the pen ends up having a negative charge. After holding the charged negative end of the pen, we notice that the handle of the charged tape was repelled, indicating that the piece of charged tape is also negatively charged as like charges repel. In the second part, we determine the forces exerted by one U-tape on another and measure the distance between them vertically apart. So we first attempt to position the two charged tapes above one another. We keep decreasing the distance until you feel the top tape is floating. We measure this distance. We know that the only vertical forces acting on tape B is electric force due to A and gravitational force. We also assume that each U-tape has roughly the same charge, which simplifies the equation we'll need to calculate the electric charge Q on the tape B. The assumptions we make is in the first part of the experiment, we assume that the charged tapes have not transferred any charge from the interaction with our hands. Basically, the electrons have not charged from our hands onto the tapes. And in our calculations, we assume that the long pieces of tape are point charges with all the charge concentrated in the middle of the tape. And each U-tape made has approximately the same amount of charges evenly distributed throughout the body. We also assume that each U-tape has roughly the same amount of charge. So the model here, the blue arrows represent the vectors of the electric forces that repel both of these pieces of tape, and the red arrow represents the gravitational force acting downward on tape B, which is equal in magnitude to electric force on tape B, which you can see by the sizes. These are the pieces of data we recorded to make our calculations. Okay, so first of all, we want to find the force of gravity on tape B. We just use mass times acceleration, which in this case is the gravitational constant, negative 9.81, and we've calculated that the force is negative 0.00159 newtons. To calculate the charge on tape B, we set the force of gravity equal to the force of the electric charge on tape B. We find that the charge is 1.303 to the power 10 to the power negative 8 coulombs. To find the number of deficient electrons, we divide the charge Q by the charge of one electron, which is 1.6 into 10 to the power negative 19. And to find the number of atoms, we divide the surface area of the tape by the length of the atoms. To find the ratio of deficient electrons to the atoms, we just divide them and find the ratio. Conclusions. In this lab, we explored how we can determine unknown charges of objects by interacting them with objects with known charges. We explored the interactions between neutral charges and known charges and have come to observe that a neutral charge will attract an object with any type of electric charge due to the dipoles that form on the neutral object. The connection between gravitational force and electric force and how they cause an electric tape to hover for a second, and how we can experimentally determine approximately how much excess charge is on a certain object after observing its interactions with other known charge objects. This is the link to my closed code, and thank you.